Anyone have this? So the first, 4 things on here, they aren't really earth-shattering properties. They're things that you probably could already evaluate. Like whenever I take the log of 1, what does the answer always have to be? No matter what the base is, the answer is always going to be what? Always going to be what? Not for this first one. So I'm looking at 318. The very first statement, I would always complete with what number? So b raised to what power over here is always going to give me 1 as an answer? 0. So no matter what the base is, if the base was 4 or 8 or 2, log of 1 is always 0. That's our x-intercept on our log graph. It's always 1, 0. And the reason is anything to the 0 power will always give you 1. So it's not really a property. It's just if you evaluate any log, you always get 0, right? The log of 1 is always 0. And then the next kind of property, if you have the base that matches the number inside, what is that always going to be equal to? 1 this time, because a base raised to the first power is always going to be itself. So it's just something to look out for. The third one, if you have the log base b of b and it's raised to a power, what is that always going to be equal to? Think about changing it into exponential form in your head. What? Not 1. We just had 1 over here when it was base b of b. What about this one when it's a power of y? It has to be y, doesn't it? Because the little base raised to the y power gives you back the base to the y power, right? You always take the little base number, you raise it to this power that's outside the log, and you get back what's inside the log. So it's this little like circular relationship to go from exponent to log form, or log form to exponent form. And then this last one is just x, and I'm going to write because inverses undo each other. So we kind of skipped that part on the notes because I thought it was a little bit more complicated to show you, but I just wanted to at least show you why on this page. So you know how for example, square root squared would just give you x, or if you had x plus 2 and you subtracted 2, that would just give you x. The b and the log base b are undoing each other kind of in this same way. So if you don't have to write this part down, but if I rewrote this as b raised to the log base b power of x equals question mark. All right, I'm not going to use x because there's already an x in the problem. If I'm trying to evaluate this to see what it's equal to, if I'm in exponential form, I can change it to log form. So the base of my log is going to be b, right? The inside part is going to be the question mark, and the log b of x goes outside, right? Little b raised to the log base b of x equals question mark. So then isn't it pretty clear that that question mark and x have to be congruent to each other because they're both log base b? So to me, this is a little bit challenging to go between the two forms because it's really abstract. But if you just kind of keep in mind that the log and the base are kind of canceling each other out and you just get x. So this wouldn't be like a popular quiz or test question, but I did want to include it as a property of logs. All right, here is kind of the new part for today. So something called the product and quotient property. So the reason I started today with reviewing exponent rules is because exponent rules and log rules are kind of tied to each other. So our warm-up question was x to the 7th, x to the 8th. What do I get? X to the 15th. I just added my exponents together. That goes hand in hand with the product property of logs. Isn't this the product for exponents? Well, guess what? The product property for logs says that if you're multiplying two things inside a log, you're allowed to separate them using addition. So you can separate them into two separate logs using addition. And it comes directly from the exponent rule. I'm not going to show you a proof of it. The best I'm going to do is just tell you that, hey, if you're multiplying, you get to add. Just like over here on exponents, if you're multiplying, you get to add. And so if I had this example over here, the log base 6 of 3 times 7, I could do the log base 6 of 3 plus the log base 6 of 7. It just allows me to simplify logs or spread logs out. The only reason you'd want to spread them out, back in the day, you didn't have a calculator with the log key. So you might not have the log of 27 available to you. You might have a chart of logs 1 through 10. So you'd have to grab the log of 3 and grab the log of 7 and add them together because they didn't have a chart up to, 1,000. So you'd have to find a product and use a table. We're going to see that when we simplify logs, so we're going to be going the other direction. I'm going to give you like a couple examples of logs that are spread out, and you have to put them back together to do one log. So it's a property that you still need to know when you're solving problems. The quotient property stems from one that we didn't review this morning, but the quotient property for exponents, don't I subtract to the 2 and I'd get x to the 4th? Same thing here. If I'm dividing inside a log, I'm allowed to write them as a subtraction problem. So log base b of r minus the log base b of s. So over here, if I have the 2/3, I might not have had 2/3 in my, log table back in the day, but I did have the log of 2, and I did have the log of 3, and I could just subtract those two logs from each other. So division leads to subtraction and multiplication leads to addition. So those are kind of two log properties that you're going to need to know to simplify log expressions. This last one is called the power property, and it comes directly from the product property. So if I had, I'm just going to show you this before I write the rule down. If I had the log of x squared, right? Couldn't I write that out as the log of x times x? Right? X squared and x times x are the same thing. Didn't I just learn that I could split that up into two separate logs? The log of x plus the log of x. Isn't that 2 log of x? So the power property, it basically skips these two steps and it takes this power as an exponent and it just brings it down front as a coefficient. So instead of having to do log of x times x, log of x plus log of x, I can jump right to this step. How many of them do I have? I have 2 log of x's. So the power property says you have c times whatever log you have. So you're allowed to bring that little exponent power down front as a coefficient, and now you just have that many of those logs. So the base and the r stay the same. The power just comes down front. We're going to use that tomorrow when we're solving logs. So on this example, I don't know what 36 squared is in my head. That's a really big number, but I do know what 2 times the log base 6 of 36 is. What is the log base 6 of 36 if you did just that part of the evaluating? Isn't that just 2? So isn't this problem really just asking you 2 times 2, which is 4? So it allowed me to evaluate this log without a calculator just by knowing that property. I don't need to know 36 squared. I need 2 times the log base 6 of 36, which is just 4. So sometimes it allows you to evaluate something that you couldn't otherwise do without a calculator. And then this change of base formula, not as important anymore because we have that math log base button on our calculator. But for those of you with a scientific calculator at home, you're going to take the log of the inside number and divide by the log of the base using your regular old calculator. Don't need a graphing calculator. So I just want you to look at your graphing calculator again. Do the math log base and evaluate that, and then try the log of 9 divided by the log of 6 done out on your calculator. So if I'm just doing the math key log base, the log base 6 of 9, 1.23, And then if I just try the log of 9 divided by the log of 6, I get the same answer. So I'm able to do this fancy calculation on a scientific calculator or my phone. That kind of makes sense? All right, so before we go on to the back, you are going to try these, just 3 questions on your own for a minute, and then we're going to go over the answers. So are these true or false? So take a guess, look at the left side. If you were going to simplify the left side, would you get the right side, yes or no? Here are answers. Did you say true or false for number 1? Why is it false? What would this side of the equation have to look like if you wanted to split it up using addition? It actually would have had to have been multiplication to start with. So if you have multiplication inside the log, that's when you split it up using addition. You can't split addition up using anything. So there's no property for an addition problem inside a log. It has to be multiplication inside the log gives you addition outside here. It's just like the same thing for if you were looking at an exponential problem. If you have x to the 7th plus x to the 8th, you're out of luck. You can't combine those, right? They're different terms. All right, what about number 2? True or false? It actually is true. If you went through the power step, now you've got 3 times the log base b of b, and we already said that the log base b of b is 1, and 3 times 1 is 3. And what'd you say for number 3? Also true. Don't you have 2 of them? You can bring this down front. You have 2 of them. So you have 1 of them plus 1 of them is 2 of them. So true. So it was false, true, true. So if those were a multiple choice question, true or false, could you get them right just on the properties of logs? All right, so this back page is just practicing the properties. The properties today have very little meaning to you. Like, why do I ever need this in my life? We are going to solve application problems with them 2 days from now. So you've got the property day. These are like baby skills leading up to like the meat. So we've got properties, then tomorrow solving, then finally Wednesday, Thursday, solving real life applications. So whether it's you found a, decaying bone in the woods and you want to know how old it is, that's radioactive carbon dating. You had a nuclear spill and you need to know how long that stuff's going to be around before it is all gone. You're cooling a temperature of a soup at a restaurant and you want to serve it at a certain temperature to your customers. So there really are mathematical applications to exponential and log functions, but we need the skills to do the calculation. So on that fishy regression page, you had to guess and check the age of the fish and the length of the fish. You want to actually in science be able to use a formula and get the exact answer, not just guessing and checking. So this is just practicing with the properties. So I wanted to just do like one problem from each section and then have you take 5 or 10 minutes and do the remainder of the practice. So let's just skim together so that you understand how to do the different sections of this. So in number 4 through 7, you're just matching them up to the correct match using the properties. So for example, 4 plus 3 can get multiplied together, right? So it's really 4 times 3 is the log of 12. Does that make sense? So if you are adding together 2 logs, you can multiply those 2 things together, and now you've got just the log of 12. So that's how you do 4, 5, 6, and 7. If you skip down to number 12, for example, they want you to represent number 12 only using these 2 terms up here, just the log of 3, just the log of 5 as A and B. So your first step would be to rewrite this. This is the log of 5 minus the log of 3, right? So how do I represent the log of 5? B. How do I represent the log of 3? A. So this simplifies into the expression B minus A. So you're just practicing that property and you're using B's and A's for all of these answers. So you might have 2B as one of your answer. You might have B plus A as one of your answers. there's going to be no logs in the final answer, just B's and A's. On 14, you're expanding the expression. So if you're multiplying inside the log, right, you would write it as the sum of two separate logs. So the log base 4 of 5 plus the log base 4 of x. So you're taking it one step further out. But on 22, you're taking it one step further back in. So if you have two separate logs, now you've got the log base 7 of 12, because 4 times 3 is 12. So you're looking to see if you're doing addition or subtraction. And then 25, 26, and 27, you're just evaluating using your calculator. You can either use the change of base formula or the math key, and then it's choice A, log base. And you could round it to 2 decimal places. I think you know how to do that. Does that make sense? So it seems pointless, but if you really have a strong backing on properties, it'll make solving so much easier. And we'll go over the answers in a couple minutes.